We're here. My name is David Regan. I'm representing Sona Nanotech, and we're here presenting to the Can-Am group, compliments of John Philpott. The main speaker today is Dr. Carmen Giacomantonio, who's a researcher, and his research lead, Barry Kennedy, PhD. As I said, I'm David Regan, CEO of Sona Nanotech, and I also have on the line Len Pagliaro, our Chief Scientific Officer. A little bit of background on the company first, and then we'll dig right in with Carmen and Barry on the study. What we have here is effectively a photothermal therapy using nanotechnology to instill the heat in tumors. Sona Nanotech, for its part, brings one key and critical component, which is biocompatible gold nanorods. We're the only ones in the world that make that. Everyone else uses a toxin called CTAB in order to create those gold nanorods. Obviously, this is critical for in vivo applications. We've partnered with Dr. Carmen Giacomantonio on an exciting study after he came visited our lab and opened our eyes, frankly, to some of the immunotherapy applications, which is his area of study. So Carmen and Barry don't need a lot of introduction here. Significant experience in the research world as well as the clinical world, and we'll let them introduce that. But first, I just want to give another quick background from Len, our Chief Scientific Officer, on Sona Nanotech and the therapy we are developing. As I said, Sona Nanotech, one thing, patented biocompatible proprietary gold nanorod manufacturing technology. It's used for both therapies and in diagnostics, lateral flow assays. Key advantages, our surfactant for those gold nanorods uses no CTAB. Amongst nanoparticles, gold nanorods are highly functional given their aspect ratio and the ability to manipulate those. Importantly, we're part of the nanotechnology characterization laboratory program, who's done extensive characterization of our nanotechnologies. Of course, the NCL set up by the NIH in the US and the FDA. Now, to tell us about how we're deploying that, oh, pardon me, one more thing. I did want to make a bit of a reference to our board of directors. We're a small, publicly listed Canadian company, but we have a board that hits well above its weight. Mark Levon in his chair was formerly head of Sanofi Pasteur. Walter Straps is a PhD and CEO of a Khosla Ventures company in Boston. Neil Fraser is a longtime head of Medtronic Canada. Dr. Michael Gross is a surgeon and corporate director, and Jim McGann has 25 years of experience and is managing director of Numis Financial. This is our operational project team, and we have advisors across the board access to have tremendous experience, including Dr. Catherine Murphy, who in fact invented gold nanorods. Now over to Len to describe our therapy very briefly before kicking off with Carmen.
Thanks very much, David. So David mentioned this is photothermal therapy, converting light into heat, into therapeutic heat, and that therapeutic heat emanates from within tumors. On the left, you see a red orb. Now, this is an electron micrograph. It's not a light micrograph, very high magnification, and those little specks inside the red blood cell, which is that red orb, are the nanorods. These are very, very small nanoparticles. They're too small to see with a light microscope, but they work incredibly well in that they can be injected systemically, they circulate through the body, they concentrate in the tumor, and they then absorb infrared light. So this is infrared light, it's not ionizing radiation. On the right, you see an illustration showing what it would look like in a colorectal tumor, where you have a tumor, nanorods concentrated in it, and then you have an endoscope illuminating the region with infrared light. In the middle, you see a scheme for how this will work in humans for treating our initial therapeutic target of rectal cancer. And so when we talk about hyperthermia, this is distinct from ablation. Ablation is used quite frequently, high temperatures that 55 Celsius and above typically, that essentially cook tissue. It's effective, but it's non-selective. The big advantage of hyperthermia is that cancer cells are more heat sensitive than non-cancer cells. And there are four effects we know about at this therapeutic temperature, 44 Celsius, 111 Fahrenheit. You get reduction in tumor volume. Tumors shrink because they're more heat sensitive. You also get killing of cancer stem cells, neutralization of cancer stem cells, which tend to be drug resistant. You increase perfusion to the tumor. So if this is used as part of combination treatment with drug, which is very likely, the drug can potentially do its job better by reaching all tumor compartments. And then finally, you get a degree of stimulation of the immune system from a release of partially denatured antigens and cytokines into circulation.
There we go. Thank you, Len. And with that, I'll hand it over to Dr. Giacomantonio.
So as David mentioned, after a brief meeting at the lab at Sona, we talked about the potential of these nanoparticles to be incorporated into some of the work that I do. And the first thing that strikes me, and should anybody that knows about hyperthermic therapy, is that the effect beyond the hyperthermia is really what we're looking for, and as Len said, potentially exploiting. Next slide. So the background is essentially, Len has talked about this a little bit. Cancer cells are particularly susceptible to hyperthermic stress. We actually know some of the pathways related to that, and it does select cancer cells and cancer stem cells, which is actually quite important in terms of the effect. The thing about the nanoparticle is that it's a precision instrument. You can actually specifically target tissue and cause thermal damage, leaving adjacent tissue unaffected. And so that kind of precision minimizes unwanted collateral cell death and toxicity. And so that in and of itself is particularly appealing to clinicians like me. And we know, and there's already some good published literature, both scientific and clinical, not using the nanoparticle, but scientific using the nanoparticle, that there is significant local tumor death and destruction. So what we propose to do is combine the local effects of the hyperthermic particle with local and systemic immunomodulation. Now, people are talking about this, but we have actually already achieved some success in the clinic. The next slide. So just a year ago, this paper came out. It's a good paper. It was a British Journal of Surgery, but it's an arm of the Nature Group. And what essentially this is talking about is combining the effects of immune therapy with several other therapies. Immune checkpoint inhibitors, the obvious low-hanging fruit, the stuff on the shelf. And then down at the bottom, you see photodynamic therapy. And photodynamic therapy, historically, people look at photodynamic therapy as something slightly different: photoactivated, light-activated chemistry. And some of you that have worked long enough in this business know that can be a messy business, and there's lots of collateral damage and lots of other consequences to that the gold nanoparticle actually addresses quite beautifully. Next slide. So our hypothesis is that we can combine these two things. We can take the gold nanoparticle, the precision that it allows, and we can modulate the immunity of the tumor microenvironment to not only enhance the cell death locally, but achieve this abscopal response that some people would call the unicorn effect. Next slide. So abscopal, we've been aware of it. Abscopal has been described very frequently in the melanoma world, first proposed back in '53 by R.H. Moll, who observed that in the context of local radiation, some tumors not only shrank, but distant metastatic disease also responded. And it wasn't until around 2004 that many of us started to look at this in terms of what's really at the root of this, what's the underlying mechanism. And it became apparent that this was likely an immunogenic common pathway. Next slide. So this has been the focus of the research in my lab and my clinical program for a number of years, and we published recently an abscopal response using essentially the same strategy with a different agent, but the principle is exactly the same. And we were successful in showing about a 30% abscopal response. It's never been actually published with this kind of frequency, and we're actually seeing more as we continue to modify the pathway. Enter the gold nanoparticle story. Next slide. So it's like radiation, where we think that the consequence of the radiation on tissue necrosis, on all kinds of other things that are beyond the scope of this talk, result in essentially the exposure of neoantigens, and the neoantigen is what we're exploiting. What we're doing is we want to combine our laboratory and clinical strategy in the context of the nanoparticles. So we've got two projects ready to go, actually. The first project, we're looking at tumor antigen, not only recognizing that we're going to generate neoantigens, we think we can actually harvest the neoantigen and reintroduce them through the immune system and create even better immunity. So that's one project that's looking at colorectal cancer, and the other projects we're looking at tumor responses, essentially to prove this abscopal effect in a laboratory environment, and actually break that down into more completely into the science of the process. So next slide. So the first one, next slide. Once we've created the response in the tumors through the effect of the gold nanoparticle, then to take the tumors, harvest the antigen, and we've got a process that we've been working on to reintroduce the antigen into the animal through the skin, harvest the secondary response, and really that's the objective response. What we'll show is two things. One is we'll show that we get effect beyond the primary targeted tumor just through the abscopal response of nanoparticle plus immunotherapy. And secondly, we're going to show that we can enhance that immune response by expanding the cells that are responsible for the initial response. The timeline for this is fairly short. Once we get the process underway, we're looking at approximately 20 days of hardcore just bench work, and then probably another 6 to 8 weeks of tissue analysis, including pretty detailed cytokine analysis, cellular infiltration analysis, and DNA and RNA analysis. And then the second project, again, this is really the elegant little experiment that should prove the abscopal effect. Essentially, what we're going to do is we know that the gold nanoparticle will create an immunogenic microenvironment in the tumor, and so by manipulating that tumor microenvironment further with cytokines, one of our principal cytokines is interleukin-2. It's kind of the linchpin of all immune activity, as most of you would know that work in the immune field, and the addition of several TLR agonists. And when you use the paper that I showed you, that we use BCG to create our effect. BCG is essentially a TLR2/4 agonist, predominantly maybe a TLR4 agonist. But there are other TLRs that we can exploit that are becoming very popular in clinical practice right now, certainly in the clinical trials world, and so create a wonderful opportunity for these two things to be aligned. So essentially, the fundamentals of the experiment are to create bilateral tumors. These bilateral flank experiments have been done in a number of scenarios. We have done and published in this in a different model, in a 4T1 breast model, where we would take one side of the animal where the tumors are involved, treat them with the gold nanoparticles, energize the gold nanoparticles, and then through a series of immunomodulation protocols within that tumor, evaluate not only that tumor, but the contralateral tumor and the animal's systemic response to the immunity generated, treating alone with immunotherapy, and then in the context of the gold nanoparticles, plus or minus various variables. So the idea, this should give us a fairly elaborate readout of exactly what the abscopal effect due to. Again, this timeline, if with a good volume, a large number of animals, we hope that we can get all the bench work done within 20 days, plus or minus, and then again, the analysis of the tissue, et cetera, will take another 4 to 6 weeks. The strong argument for its application is straightforward. It really functions as a device, and the device its role is to generate hyperthermia in a specific area. The applications are as broad as your imagination.
And now, why are you doing this?
This is there's a number of reasons. I find this compelling and very exciting, and I may be over enthusiastic about it, but I am about everything. That you have to be in the cancer world. You have to believe that you're going to make a difference. The application of this particle, not just in the primary tumor, which is an obvious target. Many of you that may or may not be in the immune world would know this notion of immune editing. And so there's a belief that, and there's evidence that through the process of the innate immune response to a tumor, the tumor cells that escape, for lack of a better word, the tumor cells that aren't affected, that eventually metastasize due to normal metastatic processes, establish colonies that are immune resistant. They've edited themselves out of the normal response. Using this technology, I can target those distant metastases, because we know the metastasis will accumulate the GMP, and that gives us an opportunity to establish new immunity in this theoretically edited met.
And that obviously has broad-ranging implications.
Oh, absolutely. For the cancers we didn't talk about, prostate cancer. Prostate cancer lends itself beautifully. It's considered a cold tumor, and again, we know that there's no such thing as a cold tumor. It's just how you introduce it to the system, and we know lots about the prostate microenvironment. Prostate mets are just perfectly situated to be targets for this therapy.
Okay, and obviously we're just going into the study in the next couple of weeks here, but how significant could this be, and what are the next steps? Even obviously there's for the therapy, but I know that the study you indicated is about 20 days, and then there's work to be done afterwards.
The important part of these studies is the proof of concept that we hope to get out of it. And there's essentially 3, maybe 4 really big things. First of all, that we do generate abscopal response that's immunogenic, or it's immune related. So to show that we've activated CGAS STING pathway. That's very important. Secondly, and equally important, if not more important, is the T cell receptor sequencing we plan to do. If we can show that we're generating, there's going to be an established innate immune response to whatever tumor that's present. If we can show that we can create a separate body of T cells directed against the tumor, that's massive all by itself. And the third thing is this sequential editing, is that we can treat a different tumor, a distant met, and get a different response from the primary tumor. It's proving that these are different. Sometimes the mets are definitely different tumors.
And do you think it'll be limiting because it's just mouse models at this point, in terms of the
it's proof of principle at this point. So most models, nobody wants another story about saving mice, but it's really the biology, and the biology we're looking for is the proof of principle that we are actually driving new innate pathways, or we're activating new innate pathways that drive adaptive immunity. So which of course is the grail. And finally, to show memory, and we've already got a body of evidence working in this line that we're not quite ready for prime time, but I can say that we are now showing memory, which is rare. That's one of the grails, is that you've actually generated memory to these sleeping tumors, or tumors that are dormant or inaccessible, or not encountered in the first pass effect of whatever relationship we have. So that's one of the things. That's one of the things we're really excited about, actually. And so this is true. We talk about personalized medicine. This is personalizing medicine, because it's exposing each person's unique immune system to their own tumor. You can't get more. That's just super exciting.
And so you'd expect regulators then to accelerate things in that.
Well, that's always their question. So a phase 1 clinical trial is a toxicity trial. You know, whether it works or it doesn't is almost irrelevant. What we need to know is that we can then bring it into the human arena safely. And I think we can all assume right now and make a strong argument that this is going to be safe.
Okay, excellent. Well, look, thank you, Carmen. Thank you, Barry. Anything you wanted to chime in on here that's Carmen, to compliment on what Carmen has said?
I'd be happy to. Len and Carmen pretty much covered it all, but I'd like to echo Carmen and I's excitement on this collaboration. Is that one of the weaknesses for immunotherapies was, this is a word that Carmen mentioned, is antigens. And we're always looking for a strong antigen, that message to get the immune cells into the cancers and attack. And we really do truly believe that these gold nanorods will produce the antigens, the powerful antigens required for our immunotherapy expertise to really create this perfect combination. And I'm coming from the research side of this all, but what I can say is both Carmen and I have over a decade in this IO field, and we know what we're looking for our readouts and our evaluation, our data to get this relevant into humans. This is going to be preclinical, but we are going to be looking at key pathways to discover the mechanism of action of this combination, and potentially even looking for biomarkers to give as much information to the regulators and the people required to get this into the clinic as soon as possible. So very excited for the collaboration.
Yeah, and based on your tremendous experience, I know you have in the research world, Barry, how much of a game changer is this, potentially?
Well, I mean, we're always looking for the that unicorn, the abscopal effect, the powerful antigen. As you know, all the ginormous companies down the States are always looking for that perfect cancer vaccine, that perfect target that you can really patent and make money off of. We really do believe that this is an approach that will give us that. And, you know, we're a small town, Halifax, Nova Scotia, a local company, local researcher, local clinician. And we really do believe that we can compete with the big boys for this and really make a huge difference in the immunotherapy for a wide range of cancers. So
I'm just going to skip ahead here to the closing page, just in terms of the company is doing a small financing given where we are and what the prospects of this study are. It's a small financing. It's to accredited investors, is of course an important consideration, and we'll be closing it in the next couple of weeks. If you have interest, please feel free to reach out and contact us. I'll provide the contacts on the next page, or feel free to click on the link that's just been provided in the chat bar to confidentially sign up for further information on this offering that is being done at 20 cents per share. We're traded on the Canadian Stock Exchange under ticker symbol SONA, and it's going to be 3.75 million units. With each unit, you'll get a half warrant for 30 cents. With a duration of 24 months. So small amount, $750,000. You can imagine that there's going to be some exciting developments even post the results of this research study. Carmen's also participating with we have a panel of experts that's forming right now with that includes a few colorectal surgeons in the US, as well as payers, importantly, in important context, provide further guidance to the company as it goes forward. And then lots of work to be done. No doubt there'll be future raises, but we are doing a minimum amount of capital raise at this time, with larger one, no doubt, on the backs of this, hopefully at significantly higher levels. Anyway, please feel free. Our contacts here are either myself, David Regan, at david@sonanano.com, or Evan Daw from our financial sponsor, Numis Financial, edaw@numisfinancial.com. Very good. Well, look, we thank you all for your time and attention on this, and hope it was of interest to folks. Again, thank you, Carmen. Thank you, Barry. And thank you to John Philpotts and Can-Am.
Have a great day.
Bye now.